Hi and welcome to KZB Academic Services, where we give you nothing but the very best in terms of academic services. My name is Mr. Kazo, and please don't forget to subscribe to our YouTube channel. It's KZB Academics, and also like and follow our Facebook page. It's KZB Academics. Now, today we are looking at index notation, and index notation is just an expression of expressing a number with an exponent, okay, or a letter with an exponent. For example, we may have a to the power m, where a is given as a base and m is given as an exponent or an index. Now, under this index notation, the exponent just tells us how many times the base is being multiplied. For example, if we have 2 to the power 5, it means that the base is being multiplied 5 times. So the exponent or the index just tells us how many times the base is being multiplied. Now, under this topic, we have what we call laws on indices, and these are 6 laws, and basically these are the ones that we are going to discuss today. Please, you can call your friends and also invite them. You share this video. This is KZB Academic Services, the best and finest academic services. Now we look at the index notation and the laws on the laws that govern index notation. So the first one is when you are multiplying with the same base. So whenever you are multiplying with the same base, you add the powers. Whenever you are multiplying with the same base, you add the powers. For example, if we have a to the power m times a to the power n, is the same as saying a to the power m plus n. Okay, and then the second law is when you are dividing with the same base. So whenever you are dividing with the same base, under indices, you subtract the powers. For example, we may have a to the power m divided by a to the power n is the same as saying a to the power m minus n. Now the third law under the laws that govern indices is when a power is raised to another power. For example, we have a to the power m in brackets, and then to the power n is the same as saying a to the power m n, where you multiply m times n as powers. So we have power of a power, you multiply the powers. And then the fourth one is on the zero index. Any number raised to the power 0 is 1. Any number raised to the power 0 is 1. It does not matter the number, as long as that number is raised to the power 0 is 1. Okay, and then the fifth law is on the negative indices. Indices, that is the negative index. So if we are given a to the power negative m, that is the same as saying 1 over a to the power m. Okay, whenever you are given a to the power negative m, it is the same as saying a to the power it's the same as saying 1 over a to the power m. Okay, and then the last one is where we look at fractional indices. For example, if we have a to the power m over n, or the index is a fraction, which is m over n. In that case, the denominator, so we have m over n, the denominator, which is n there, it tells us the root. So that is the nth root, and then the m there is just the power. The numerator is the power. So we have the power, and then we have the root. So we have the nth root, and then we have the power. Okay, so these basically are the laws that govern indices. Okay, now we are going to discuss some of the questions and also how we can apply these laws. And these questions, they come in mathematics paper 1. Mostly they are some of the from the first 5 questions that is under national assessment in mathematics. Okay, so here's an example on the board where we are given say evaluate, this is 27 over 8, that's brackets, to the power 2 over 3. 27 over 8 to the power 2 over 3. So there you can see that the root there is 3, which is just the cube root, and then so we have cube root of 27 over 8, and then to the power 2. So there we can simplify it. As you can see there, what is the cube root of 27? The cube root of 27 is 3, and then the cube root of 8 is just 2. So we have 3 over 2 raised to the power 2, which is just 9 over 4. Okay, this is how we apply these laws of indices. Don't forget to subscribe to our YouTube channel. It's KZV Academics, and also like and follow our Facebook page. It's KZV Academics. My name is Mr. Kasov, and